So let's hand those up and over now, please. One. All right. So, if you have your phone out, as of right now-ish, you should be getting a message if you signed up through Remind. So raise your hand if you just got one on your phone. All right. So what you're going to want to do is, and we'll show you, if you're not, we'll show it on the computer as well. But if you click on that link that I sent you through your phone, what's popping up? Yeah, there's a little file, and you can click on that little file, and when you click on it, it's going to open up and give you something. And what is it that I just sent out to you? Should be the answers to, let's see, now you guys are Enriched 4. So actually if you log in, either choose the one on your phone, or this is what it looks like on, goes this way, yeah. Here is the same thing that was sent out to you through Google Classroom. This was the answer key to what you just took and handed in, okay? So you'll know very, very quickly whether or not, and I put 3 different people's papers in so you can see, what the different work is. Now, we get to this point, and I say it not to begrudge you, but somebody from one of the other classes in the beginning, and again, please don't misconstrue, not angry. Each question, if you got it right, was worth 1 point with the justifying work. What I mean by justifying work is, right here, I noticed some of you go through, and it's a gimmick, and it's a multiple choice thing, and if I learned from my mistake, we won't give them this multiple choices next time. You went through and you started foiling these choices until you got the one that worked. If you got the right answer, you got half of a point, because it says factor it by grouping. It doesn't say try it by guess and check or whatever this is for. So if you got it right by doing the FOIL, you got half of the point. You need to make sure, though, that you show this out. Somebody from the other section goes, and then they came after class, they didn't, it wasn't a sloppy crowd. But they just went through and said, I didn't get to finish the assessment, and, it was, and I went through, you all had 10, actually 11 minutes to go through and finish, was it 5? 5 total questions. And I said, all right, that's a little bit over 2 minutes a question if you came in right when the bell rang. And most of you get here pretty early. And so I said, well, show me the homework that you did. You go, oh, well, I didn't do it. Well, and that's another thing. It wasn't I didn't do it the first time. It was when I said, show me the homework that you did. They go, it's in my folder that's in my locker. And I go, oh, okay, well, why don't you go get it? Well, my locker's on the other side of the school. That's fine. I've got all day, and my chair is very comfortable. You can go over, grab it, and come back. Well, never mind, then I didn't do it. Okay. So again, I'm not angry that you didn't do it. I don't get offended. But understand, it's the part that should just be honest with each other with someone. So, if you didn't do the homework, it will take you a lot longer. We need you to be sort of more automatic with things. And make sure when you see this, you do this, and you keep taking them further. There was one, too, that I did want to point out here. Now, this was on some of your papers. This was the one, most of all, looking at it from the first grouping, the class average was a 4, for the first 3 classes, was a 4 out of 5, which was good. That means, by the way, you're getting 4 out of 5 questions right. Now, when I was looking at it, though, a lot of you got to here on this question, and you put for answer 3, you put down A. Who can tell me why A is the incorrect answer for 3? We only have 2 of you who see it. Who sees it? Yeah, look at here. There's still a GCF, so you can keep going further. So if you did miss it, don't get upset. And by the way, it's 5 points. The tests are 100 points. In the beginning, we ease them. As we go through, the assessments get worth more points, but we're easing you in. I get that a lot of you are not used to coming in and having an assessment waiting for you every day, something that's graded, blah, blah, blah. Now, so make sure that that's the case. One other thing that I just remembered that I forgot to go over with the other sections. We talked before about the academic honesty piece. One thing too that happens, that will happen for all of you, is you'll have a day when on test days, when you come in, you'll see, and I'm trying to make the strips up now, but you'll see, and it'll just be by out quarter. From here over to here, I have a great big giant ledger. And all you're going to do when you come in is you're going to take and put your phone right under there, and you get it back right at the end of the period. You can put it on, you can be that person who puts it on vibrate, and if you get 10,000 messages, it will literally be shaking on this, and it goes like this the whole time. It's very frustrating, or whatever. If you want to leave it like that, you're free to. But we ask that you leave them up front, because one thing that I found out was happening last year with some of the kids was that during a test, again, why? You all actually would be the recipients of it, but why do people in one section would take a picture of a page of the test and then send it? I'm not asking whether or not you did it, and this is a totally free. Who here has heard of, knows of things like that ever happening? See? Okay. Thank you for the honesty. I can assure you, once I find out some of the ways that you all cheat, we do everything we can to tie box. So you'll just leave your phones up here. I don't go through them. I really don't care to see what's on your phone. And leave them there. That's fine. You take them with you at the end of the period, okay? Because that's the other thing. People go in the bathroom for 2 hours with their phones and then come back out. So just make sure, please, that you understand, we'll leave them up here. It's for everybody. I'm not accusing anybody of cheating at all. I'm just saying I'm going to make it almost impossible if we can. Now, we left off last time on this. So the reason I had you take the computer thingies out was just, if you go into Google Classroom, you'll see this as a posting. Oh. You'll see this as the posting. All of you got the same thing. I made sure that I posted it after most of you all took it and handed it in. Another thing too, and I don't want to begrudge other colleagues, and I don't want to overgeneralize, but there's some teachers in the building who consistently hold people back for other things, and I don't know why. Whatever. And let that teacher know if you are coming in late. You get like a bonus 2 to 3 minutes the quicker you get in here, because I start my timer from the bell. So if you get in, 2 or 3 minutes before the bell goes, you've got 2 or 3 minutes extra time on your assessment, especially if you're one of those people who knows that you need to take a little bit extra time. So make sure, please, if that's the teacher, to say, hey, I gave you my 55 minutes. I have to get to my other class. He's really, really old and cranky and mean, and we have an assessment waiting for me. I really don't care about you. I'm more concerned with math, because that's the best question. You can say it sometime. But in any case, so if you want to go through later and check to see how well you did, again, it's 5 points. If you got the right answer, but didn't show the factorization part of it, you get 3.5 out of it, or half of the point. Okay? So you can put that other stuff away. Oh, by the way, who was able to successfully go through and do and get signed up for Math Excel? Are we almost up to everybody-ish? Okay. This weekend, I'm going to post an assignment for you. I think we'll look to have it done by Wednesday, but it's literally just the introduction on how to use Math Excel, which means, like, because the typing of math on the computer is always an issue. Like, so if your answer is x squared, type in x squared, and it shows you how to do it. And one of the questions, I think, actually was like, if you solve this equation, the answer is 5. Then it says, in the answer box below, type 5. That's it. Right? It's supposed to be really easy. We'll give you, like, until Wednesday to go through and do it. So you can take those and put those away. Have out on your desk the note packet that we went through and worked with the other day. Please. And I think we got through all of this. All right. So we're going to have you do to start. Bounce over, please, to page, I think it's page 6. Yeah, page 6 here. Now, we're going to be talking about, from what I understand, some of you did some of these factorings before, but I'm going to treat it as though you've never done any of them. So we did GCFs, we did double and triple GCFs. We also did difference of perfect squares. Today we're going to talk about a sum of perfect cubes factorization pattern and a difference of perfect cubes. You have to know that some numbers are perfect squares and some numbers are perfect cubes. 1 is a perfect cube. You get it by taking the number times itself 3 times. So 1 cubed is going to give you 1. 8 is a perfect cube. You know that because 2 times 2 times 2 is going to give you 8. 64 is etc. So go through right now. Make sure you write out the first 7 perfect cube numbers someplace on there. We're going to be doing example 3 on page 6. It says page 6 at the top. That's how you can tell it's page 6. Now, you want to list those numbers out first. Again, we start off 1. Yes, 1 is a perfect cube. It's also a perfect square. It's also 7,000 things. 1 is the awkward duck. But 1 is a perfect cube. 8 is, 27 is. 3 to the third power is not 9. It's 27. 64 is 4 to the third. 5 to the third is 125. 6 to the third is 216. 7 to the third is 343. Normally, you don't get a question higher than that. So I go through and fill those in. And then the next thing is this difference of perfect cubes factorization pattern. Now, it's awkward in the beginning, but after doing it 1 or 2 times, you should be good. You have 1 cube minus another cube. It breaks down into 2 prime expressions. One is a binomial and one is a trinomial. The binomial would be, and I say left minus right instead of x minus y. You'll see why when we do it in a minute. But this would be left minus the right. Then the trinomial is left squared, left times the right, and then right squared. The big thing that you have to remember is what your signs are. So if it's a difference of perfect cubes, you're automatically going to have a binomial and trinomial, and the 3 signs going across are minus, plus, plus. We'll see what it looks like in practice in a minute, but you want to have that formula down. Don't stare at it. Pencil and paper. Now, when I look at this first example, we'll have you, once this is done, put your pencil right flat down on your desk. And I want you to fight the urge to write something because we're actually going to walk our way through it, and then you're going to give me an answer. I'm going to hold your hand through it like you're a baby first. Now, I'm going to factor this down. Is there a GC, and our checklist always works like this. Sometimes I'm a little bit of a lazy Larry and I don't go through and say it, but I go through it with my head. Always check for a GCF first. Look at A. Is there a GCF besides 1? No. Is it a difference of perfect squares? No. We haven't done any of the other factor patterns. There's no GCF though. Is this a sum of perfect cubes? No, because sum would mean addition. Is this a difference of perfect cubes? And that's absolutely. So when you're allowed to pick up the pencil, what I always have people do is list the cube root here and here. You'll do that when I tell you to pick up your pencils. So I take the cube root of the left and then the cube root of the right, and I write it down. So I can go and reference it in a minute. It's not some sort of math magic where it comes from. Now to start this off, I'm going to have a binomial factor and a trinomial factor. The signs going across, you'll fill in, are minus, plus, plus. And the binomial factor is going to be left minus the right. So when I do this to start, I'm not going to write this down yet because we're going to condense and simplify and just let's have one final answer. It's going to be left minus the right, so the binomial factor would be an m minus 2. Left minus right. And when we say left and right, it's the left and the right. The next one's going to be a trinomial. It's left squared, left times right, right squared with addition between them. So if I were to take the left and square it, it would be this term, or an m squared. And then I'd have a plus sign. Then I take left times right, which would be m times 2. And then I go through and I take the right value and square it. Now, I wouldn't expect you, and when we go to give your final answer, you all are big kids and you're in an honors level class. I really don't want to see this step on your paper. You can go right down and hopefully we're good enough to simplify this out. Looking at what's here, what would the binomial be? Well, it would say an m minus 2. When I say let's simplify this out, you can tell me, hands up please, you can tell me what you get if you did the operations and expressed it in the right format for that trinomial. We got 1, 2 of us. That's it. It's not supposed to be tough, it's supposed to be kind of easy. What do you want to say? No. Take a look at what's there. Just combine like terms if you need to. What do you want to say?
M squared times 2m.
You said one thing incorrectly there.
Plus.
Plus. So if you list this out, it would be m squared plus 2m plus 4. Now you can pick up your pencils. This is the only part I would expect you to see on your paper. You have to be with it enough to go through and take that little bit of a step and say, all right, when I take the right squared, I don't need to write 2 squared. I mean, if you do, that's fine. But we really should be doing that computation in our head. Questions on that one? Let's look, please, over at the right-hand side. If we do this on the right-hand side, there is not a GCF. It's not a difference of perfect squares. It is a difference of perfect cubes. Hands up, please, if you can tell me the cube root of the left-hand side, or that number I'd fill up top. 3. Close. 3x. Hands up, please, if you can tell me what I'd write up top. What's the cube root of the right-hand side? Now, I'm going to ask you, list out enough space for a binomial factor and a trinomial factor and fill in the sign. So small parentheses, bigger one, enough space to put those terms in it. And the signs going across, again, are minus, plus, plus. So give me the frame of it, and then we'll fill it in. Hands up, please, if you can tell me what the binomial factor for this is going to be. We'll wait for 6 of you. We've got 1, 2, 3. We can do better than that. What would our binomial factor be? We're up to 4 of us. 5. Perfect. Now, there's going to be, I'm going to give you, let's say 30 seconds to get a head start on the trinomial. I'm going to tell you that a lot of you will make the same mistake when you did the trinomial, and it's okay. You'll make the mistake the first time, and after that, you won't make it again. Go through and give the trinomial a try now. Remember, it goes left squared, left times right, right squared. Those are the 3 terms to fill it in. Tell me what they think our trinomial is going to be. 1, 2, 3 of us.
3x squared plus 6x plus 4y.
Close. You made 2 little errors in there, but one of them was the error that I thought everyone would make. What do you say?
9x squared plus 6xy plus 4y squared.
Perfect. When you do this, there's going to be a lot of you who list out a 3x squared here and a 2y squared here. Who did that? Who gave it out as a 3x squared 2y? What mistake did you make? You got to square the number in front, that coefficient. Okay? And again, you're going to do it the first time. Because remember, it's 3x times 3x. 3 times 3 is 9. X times x is x squared. You won't make that mistake the second time. Now, questions on this one? Take a look, please, at this next one. Now we're going to factor the sum of cubes. You can't do the sum of squares. You can factor down the sum of cubes. Look at the formula that's up there, please, and write it down now. It's the one with the blinking lights around it. Give me out what that formula is. And hands up, please. It's very similar. What's the only difference between the difference of cubes and the sum of cubes formula? Take a look. What's the only thing that changes as I go from one to the other? So it's not a ton of memorizing here. What do you want to say? Yeah, as you go through, the only thing that's different is going to be the signs. So where before it was minus, plus, plus when I filled them in, now when it's a plus, it's going to be plus, minus, plus. So understand, these are the things you've got to remember. The factoring pattern is the same. The only thing that's different is the signs. Now, I would expect us to be able to get A done 100% of the time. Looking at what's there for A, I'm going to take the cube root of the left and the cube root of the right and write it up top. So the cube root of the left here would be an R. Cube root of the right would give me a 3. On your paper, you're going to list out space for a binomial and a trinomial. Hands up, please, if you can tell me what the binomial factor would be. We've got 3. What's that? That's terrific. How about what our trinomial is going to be? Hands up, please, for that. We've got 3.
R squared minus 3r minus 3.
The last part, please. And what did you say the sign on the 9 was?
Minus 9.
Other way around.
Plus 9.
Plus 9. It goes plus, minus, plus. Now, questions on that one? Extend yourself, please, and do question B on your own. Hands up, please, for the binomial factor. Okay, we were 3 people. What do you want to say?
3z plus 5.
Hands up, please, now for the trinomial factor.
9z squared minus 15z plus 25.
I'm guessing almost everybody got that first term right this time, when you take the 3z and square it. Questions on that? All right. I'll tell you right now, I'm going to give us the breakdown of 6, what those cubes are, and I'll tell you, E is probably one of the toughest ones we're going to do today. Let's take a look, please, at C, though, first. What is the cube root? Hands up, please, if you can tell me the cube root of what's on the left for C. What's the cube root? Go ahead.
5z.
Hands up, please, if you can tell me what the cube root of what's on the right is going to be for C. This is the one that's a little bit tougher. And it's, you'll do fine. Take a chance. What do you want to say?
6x squared.
Perfect. That's great. Now, the reason why it's 6s squared is you're asking yourself what times itself 3 times is going to give me s to the 6th power. If it's s to the 3rd 3 times, that would give you s to the 9th power. So, knowing that, now go through and fully factor out C. The binomial factor you should get right all the time. The trinomial, this again, it's a push. Hands up, please, if you can tell me what your binomial factor would be for C. Okay. Now, this is the one that's going to be the tough part. What do you want to say?
C squared minus 30s squared t plus 36s equals 4.
You're right. Absolutely right. Does it matter that when you said you put the s squared before the t in the middle, is that right? Did I hear you right? Does that make a difference? No. Not at all. Questions on that? Now to start off question E, again, the first thing on our checklist all the time is to look for a GCF. There's not one there. It's not a difference of perfect squares. It's not a sum of perfect, or sorry, it's not a difference of perfect cubes. It is a sum. So what I need to do is take the cube root of the left and the cube root of the right. So I go through the cube root of the quantity x plus 2 cubed is just, and then the cube root of t cubed is that. Now, you're going to list out, and I say it, and I say it's a binomial. The problem is we got a binomial and a binomial, which creates a trinomial. Looking at what we've got now, I'm going to take this in pieces. I'm not going to try to do too much. But and this is a question, again, it's definitely an extending question. This is only, I wouldn't even attempt it in a regular Regents class because it's tough. There's a lot that's going to happen here. But by no means, it's not like we got new ways to multiply or divide. But there's a lot that's going to be happening. So I'm going to take my first binomial, and that part's going to be easy. Hands up, please, if you can tell me what the first little binomial pieces, even though now it's going to be a trinomial.
X plus 2 plus t.
There you go. Now, when I did it this first time, I used color so you could see which is which, and I didn't. Now, do the parentheses need to be there? Yes or no? I would argue at this point, no. Can anybody tell me why? Well, let's say this. What falls apart if they're not there? Does anything fall apart if they're not there? Because you have, what's the leading coefficient? What's the hidden coefficient in front of those parentheses? 1. You distribute out of 1. Are you changing anything? No. So I can even tell you in my final answer, it looks like this. The part that's going to be awkward is all of that business that you're going to have to show on the right. So the first time through, I'm not going to be a mental math officer. I'm going to show it out nice and slow. And when I do that, I take the left squared, which is the quantity t plus 2, and I square that, minus the left times the right. And I even listed it out as left times right, plus the right squared. Now this opens up a whole new mess of algebra that we're going to have to do. I've got to first take the quantity x plus 2 and square it. This, to me, is very frustrating. If you were to go through and take the quantity of x plus 2 and square it, we still have some who would tell me that this is what this would be. Is that correct?
No.
You're going to have to remember, and I apologize, I am proudly, well, I guess I wouldn't say proudly, but I openly acknowledge the bigotry that I have for that magic rectangle or the squares of fun or whatever it is. I call it foiling because I listed out as first, outer, inner, and last. But there are some, when they go through and show, did we go over, did they show you that, is there like a 4 rectangle or like an awkward rectangle or something that they give? I'm very old, I'm very stubborn. I don't ever, you can do them if they're yours. Well, you got to do what works for you, but when we do them in class, you will never see me list out, like, and what do? You list the binomials or in triangles on the side or something like that? Is that how that fun square works? Yes? You know what I'm talking about? Look, you're all mute, we don't talk. Factor cubes? Okay. Wonderful. I'm openly prejudiced against factoring cubes. I'm not a huge fan. If it works for you, do it. I could care less. I'd rather you get it right than go through and try to make me happy. But when I do it out, that's how I do it. So I'm going to list this out, and I've got my first terms I need to multiply together, which are these two here, which would give me an x squared, plus the outsides and then the inside, so it's a plus 2x and a plus 2x and then a plus 4 at the end. I'm going to combine like terms now and list that out, and I've got this. And by the way, should you all be able, raise your hand if you would be capable of doing that multiplication in your head. Some of you, by the time we get out of here, I can guarantee you will. Because there's times when we do it, you'll have little chicken scratch over in the corner, and that's fine. But I'm not going to muddy up this question by showing out all this in the middle of it. Now, once we get to here, that took care of this piece here, taking the quantity x to 2 squared. Now over here, we said this before, does the order with multiplication matter? Yes or no? No. So I can really move this t in front and then just distribute out a negative t to these two terms. And that's the next thing that I did. And then the end is done, and that's xt. Are there any like terms I can put together? I don't see any, so that would be what your answer is. Is it long and difficult? Sure. Absolutely. But it also shows me how much algebra you all are capable of doing and how far you can really extend yourself. This is a great question to see how much you can go through and push. Now, that ends. If you need more practice questions, these are sum and difference of perfect squares. By the way, I gave you, again, all of the formulas for sum and difference of cubes. Difference of squares, you really don't need to know the perfect square trinomial one. Over here, there's more examples that go through. All of these are sum and difference of cubes down here. I think that these are factor GCFs or difference of squares. You need to do enough to make yourself comfortable. We've got one more topic we're going to cover today, one more type of factoring. So bounce over please to page 3. This is one you all tend to be really good at because they train you like house pets to go through and do this when you're in 8th grade. We need to factor down this trinomial. Now, the first thing that we're going to go through and do, is there a GCF? Yes or no? Nope, nothing goes into everything. Next thing, is it a sum or difference of perfect squares? Sorry, sum or difference of perfect cubes? No. Is it a difference of perfect squares? No. That's what we're stuck with. We got this. So, when you have one like this, you're going to list out 2 parentheses, and we're going to start filling in. Now, I always ask that kids show this one step out because it builds your number sense, because a lot of you, some of us even struggle with basic number facts. You need the calculator to like take 2 plus 6. So when we do this out, there are 2 factor pairs that give me the 35 at the end. Hands up please if you can tell me just one out of the 2 factor pairs of 35. What do you want to say? And what one were you, do you have one? There you go. So I list out 7 and 5, and then there's 1 and 35. So I've got my 2 factor pairs. Now, I need to find values that multiply to negative 35 and add to positive 2. Hands up, please, if you can tell me what those values are going to be. Okay, so do you know what the 2 binomial factors of this will be?
Plus 7x and 5x.
No? Oh, some of you, your teacher might have shown you a different way to do it. That's one way I guess of starting it, but I stay away from that. You can break this down right away.
X plus 7 and x minus 5.
There you go. So I'm going to break this down into these 2 binomials right away. Right away. You can do that if the leading coefficient is a 1. Questions on that? On your own right now, please do A and B. Hands up, please, if you can tell me what A will factor down to. We've got 3 of us. Oh, 4. What do you want to say?
X plus 5 and x minus 5.
No. You're very, very close. Now, the reason I say that is, again, your goal is to get yourselves ready for AP Calc. I can't tell you how frustrating it is, the number of kids when I'm grading pre-response questions for the Calc exam that change the variable because they drilled into you. It's always the x comma y. That's not mandatory. It can be a comma b, it can be m comma n, it could be a comma z. Make sure you stay with the same variable. And I'm going to try to make sure that that happens. To get you used to it, I'm going to mess around with what variables we work with all the time. Take a look, please, at B. Hands up, please, if you can tell me what we would get for B when we did the factorization. Go ahead.
W plus 4 and W plus 8.
Now, to check your answer, you can always FOIL it out. My first terms give me W squared, outside gives me 8W, inside 4W. And so that gives us the 12, and then we multiply and get the 32. So those were questions on that. All right, go through right now and factor down number 2 on your own. No, do the one to the left. If you're asking about the one on the right, though, for example, 3, it's minus 16a squared on the right. Who can tell me, please, what we got when we factor down number 2?
7 and 10 minus 1.
All right, so I'm going to go through and list this out. Now, when we do this, we've got the quantity m plus 7 and m minus 1. Now, let's just double check and confirm. I've got m squared, that works, negative 1m on the outside and 7m on the inside. That gives me the 6 that I'm looking for. So is that right? You fell for it. You know what? Did I tell you the screen door analogy?
Yeah. Yeah.
There's another screen door. And I'm going to throw screen doors at you all the time. You gave me a terrific, beautiful face imprint. I'll never wash it. And I know that a lot of you did. I know a lot of you did. 'Cause I see all these pencils. Who can tell me what that factors down to? We got 1, 2 people. 3. Yeah. It doesn't factor. Now, what do we call something, by the way, that doesn't factor? Now, here's the one thing that maybe will make you feel foolish. That's right next to it, recognizing that you're factoring and drawing. But here's the thing that I find so funny. I was working, because again, kids always struggle with this. And I said, I don't get why, because obviously I'm amazing at teaching it to you all, because I'm amazing at everything. But I went through to the middle school people, and I was like, can you show me how you all do factoring? And I worked with somebody, she was terrific, she showed me this worksheet. I see, she gives me a sheet of 500 factoring questions. God, this is so terrific. I bet you every situation you're going to ever encounter on this sheet. So we went through, and she's like, oh, they love it. And they do all of it. And she was talking about the Enriched students. And they really see the connection and do a fabulous job. So I go home and I take the sheet and I'm doing that, and I get to like 83 or 85, and I sort of give up. And I'm feeling frustrated. And I walked in the next time that we met, and I said, I sit there and did all of these 80 questions, and not only would I never give you like 80 questions to do, because that's offensive to your intelligence. If you can't pick up on the pattern after, let's say, the first 50, you might have a little bit of an issue. But the one thing that was most startling was I said, you have 500 of these, I'm assuming? She's like, yeah. And I go, how many of them don't factor? She goes, they all do. Why? You're going to be encountering quads all year long. Some of them factor and some of them don't. You have to break that math. You have to be like the math thinker, as opposed to, and again, there's a lot of you in here who have profoundly strong work ethics, and that's what makes you an enriched student, is that you're a worker. No one will work harder than you. No one will outwork you. And then some of you are math thinkers who, in all honesty, you see it, you write it down, you go home, you don't do any homework, you see math easily. High school is going to be a breeze for you, and in college is when you're going to hit the brick wall. But we're sitting here going, do you need to recognize that some of them don't factor? Sure. So why are you doing a disservice to me by saying everything I'm giving you 500 times over is going to factor down? We're going to encounter tons of them that don't factor, and I need you to be with it enough to say, yeah, that's not going to factor down. Now, let's look at the next one. It's going to have 2 variables in it, which means it's going to be the same level of difficulty. I'm going to go through and give out 2 sets of parentheses, and in these first positions here, I need to have stuff that's going to multiply to give me this. And the second positions here and here have to multiply to give me that negative 16a squared. Now, I'm lucky, because to fill this in the beginning, hands up please if you can tell me the only thing I can put in those yellow positions. Just an X. Now, the awkward part is, who can tell me what my candidates are? I don't need the signs. What are the candidates that I have to get a 16a squared? What's one pair of candidates? Careful. I said 16a squared. Yeah. 8a, and then? Good. Who can tell me the other way I can get 16a squared?
4a and negative 4a.
I'm not going to assign a sign to them just yet, but those are the 2 ways that I can get it. Now, we're going to guess, and we got our candidates. We're going to check to see which ones work and which ones don't. This, I'd say, let's try plus 8a and minus 2a. Let's see if that works. So we do this. I've got x squared. The outside gives me negative 2ax. The inside gives me the 8ax. So did this work? Yeah. And if it doesn't, you know what you do? That's why God invented erasers. You start over again. You try another one. And you just keep trying until you get the one that works. Take a look at example 4. Hands up, please, when you can tell me what you would do to start out number 4. I'm not going to say it. I've said it enough that I've screwed it up. Go ahead. Careful. You're on the right track. It's the way that you said it. Perfect. There's a GCF in there. So you don't divide out. We got to factor it out. If it was an equation, you could divide it. So I'm going to take out a 16y. And what's left after you take out the 16y?
Y squared minus 2y minus 3.
Now, you have to ask yourself, can I go forward from here? I told you I'm a pusher. There's always, most likely, there's going to be more to do. We're left with this trinomial. Is this prime? No, you can keep going. Hands up, please, when you can tell me what the fully factored version, or fully factored answer is going to be. We've got 1, 2. Go ahead.
Well, 16y times y plus 1 times y.
Does the order of them matter? No. Now, we're not going to finish, but I'm going to keep going until we get to the bell, because again, I'm a pusher. When I do this next one out, I'm going to factor no GCF. It's not prime. I need values in the front here that are going to multiply to give me 12r squared. I need values over here that are going to multiply to give me -2. You're going to hate seeing 12. You're going to wish it was an 11 in front. You're going to wish that you had a 91 in front or 101 in front. Why don't you want a 12r squared there? Hands up, please, if you can tell me why you don't want it. Not a perfect square. No. Why would I want to stay away from 12r? I'd love if 17 was in front. Yeah. It's not prime. You have all of these pairs here, I listed them out already, that can go in these positions. Now, all right, your assessment next time is going to be on. Let me just double check and I'll tell you right now. Stuff that you need to know. You need to know how to do factoring completely, GCF, sum and difference of cubes, and grouping. Okay? You need to know how to do the factorings we've done so far. Don't worry, they're free response, not multiple choice. So you can't fake it. Make sure, do enough to make sure you know what you're doing. If you need to rewatch what we did today or another section, please do it. Have a great weekend, kids.